Hey, good evening. This is Mr. Benning, and we want to go ahead and quickly go over Chapter 9 and look at the equations, look at how to do all the quadratics in the different forms, just so we've got a brief understanding of what's going on. So we got 5 things we're going to look at. So we're going to move kind of quickly. So the first thing that we're going to look at is graphing. Remember that graphing is really just good for an estimate. So we may or may not get the exact zeros, but we'll do the best we can with this. So the first thing we want to look at is we want to make sure that all of these are in standard form, or in quadratic standard form, meaning that they are in the form like f of x equals ax squared plus bx plus c. And again, even with all of these, I'm probably going to go quadratic form, but I do want you to be able to find the zeros on these. At least that you're able to find the zeros. So now, once it's already in standard form, I'm going to go ahead and graph the equation. I'm going to go ahead and first, when I'm graphing the equation, and I want to go ahead and just give a couple things, is that I want to find the vertex first. So my vertex, or the axis of symmetry, remember, we can find by x equals minus b over 2a. And so we need to know what a, b, and c are. By the way, if we're doing this, we probably just want to use quadratic formula. But it's okay. So let's go ahead and do that. Minus b, so that ends up being 5 over 2a, which is 2 times 2 or 4. So my x, or my axis of symmetry, is at 5 over 4. So now we want to go ahead and start to graph everything. And so I like to put things in the middle. So we're going to draw a table. So I know I'm going to put 5/4, which is 1 1/4, in the x side of it, and the y I've got here. So we're going to go similar distances, so make my life a little more hectic. So I am going to do this. I am going to go with the 5/4, or the vertex. This one I might do a little bit different. I'm going to have to do this one a few times. So let's go ahead and put that in our calculator. So on my calculator, I'm going to go ahead and pull up Desmos, delete, and I'm going to go ahead and type in my function f of x, and you can do this with the calculator, equals, and let me get my formula real quick. It is 2x squared. So we start off with 2x squared minus 5x. And we graph it. I'm just going to go ahead and graph some of these points. And plus 5. So we're going to go with plus 5. So my vertex. Let's go ahead and talk about this one. And I use it for a calculator, but my vertex, when I graph it, is I'm literally just going to put in f of 5/4. And I end up with 1.875. Great. And so we have a vertex that I'm going to go ahead and say a couple things about it that I'm going to know. One, that it's going to be 1/4, which is somewhere right here. One, and it's like right here somewhere. All right. I know my 0 is at 5, so it's 1, 2, 3, 4, 5. So I know 0 is at 5. I'm going to do a couple more f of. We'll say -1 is at 12. I don't know if I got 12. It's at 6, 7, 8, 9, 10. It's up here. So -1 and 12. I can already tell you right now it's not looking good to get a solution. So we're going to go f of 2. That's 3. So I've got 2, 3. So that's 2 and 3. I know this is going to look a little weird. And then I'm going to go 3, which is 8. 3, 4, 5, 6, 7, 8. So it's a little different than how I would, but this one is going to go straight up like that. And so notice it does not. So my next step, once I do that, I find my x-intercept. Notice there are no intercepts. It does not cross the x-axis. So what I'll say is there are no solutions does not cross the x-axis. And that's all you gotta do. You just look for where it crosses. So it doesn't matter necessarily where it crosses at as long as it does cross. This one does not, so there's no solution. All right, simplifying radicals. There's a couple ways that we can do this. Remember that multiplying and dividing, as long as the radical is the same, we can multiply or divide all we can. We can separate out all we can. So let's look at a couple things like this. So I can sit there and say, all right, 128 over 27. Well, I'm going to rewrite this with the radical over both the top and the bottom. So I'm going to have radical 128 all over radical 27. So let's go ahead and simplify the top. Well, that is radical 4. Because 4 go into 128 times, so we need to find out 128 divided by 4 is 32. 32, I know 16 will go into, so I'll have radical 16. Let me write that 32 at step. Times radical 32, which equals radical 4 times radical 16 times radical 2 all over, and 27, 9 will go into 27, and that's 9 times 3. So again, I've got radical 9 times radical 3. Let's simplify our radicals. Radical 4 is 2. 2 times radical 16 is 4. Radical 2 all over 9, which becomes 3 radical 3. And so the top ends up being 8, because that's 2 times 4. 8 radical 2 over 3 radical 3. But I can't have the radical in the denominator. So what I need to do is multiply the top and bottom by whatever the radical is in the denominator, especially the square root. So we multiply. So radical 3 is in the denominator, so we go radical 3 over radical 3. And when you're simplifying these anyway, you need to use perfect squares to break this up, so just as an FYI. So we're going to multiply this out. Notice I got the 8, no number under the radical, so I've got 8 out front. 2 and 3 are both under the radical, so I can multiply those together. So that becomes radical 6 divided by radical 3 and radical 3 is 3. 3 times 3 is 9. So that becomes 8 radical 6 over 9. So let's look at example 3. I'll make this a little more clear on this when we're simplifying the radicals. We want to look at numbers that go into 324, and we want to do it by perfect squares. And the simplest and the smallest one besides 1 is 4. So I usually use 4 if it's an even number. Because usually a lot of things would go by 4, go by 8, or go by 9, or maybe even 25. So let's go ahead and do, will 4 go into 324? Well, yes, it does. So I end up with radical 4, and that's 4 times 81. Well, 81 is a perfect square. Well, that kind of makes my life easy. The square root of 4 is 2. The square root of 81 is 9. 2 times 9 is 18. So square root of 324 is 18. I'll rewrite that again. Not too bad then. So let's go ahead and look at solving square roots. When you solve square roots, make sure you get the number by itself. Okay? So make sure you get the square by itself. Here's a couple ways you could see it on the test. One, I can have just a plain w squared minus 3. Again, I could go quadratic formula, but I probably won't. It doesn't even make sense because this is a lot easier. And the same thing with 5. I'll do a different way on number 5, but I'll show you what to do here. So this one, if you can solve without the square, you can solve it with the square, but we're just adding the next step. So this one here, I could get the w squared by itself, so we add 3 to both sides. The 3's cancel out, and I'm left with 27 equals 3w squared. Divide both sides by 3. We end up with w squared equals 27 divided by 3 is 9. Once you get this part, you got the square root, both of it, and you get w, because that's what undoes the square, and you have the square root of 9, which is 3, but not only 3, but also negative 3. So you'll see written out plus or minus 3, or you would say w equals 3, or w equals minus 3. One of the two ways. Both of them are okay. Now, example 5 I have is that we want to look at substituting what's in the parentheses for a letter. So I can say, well, the parentheses, that's 2z minus 5. We'll make that any letter. Well, I'm going to make that an R. So R equals 2z plus 5. And I'm going to take this R, put it where that is in the parentheses. So I'll have 2r plus 4, r squared plus 4 equals 36. We subtract 4 from both sides. Just like I did before, 2r equals 32 divided by 2. R equals, or r squared equals 16. Take the square root of that, and I've got r equals plus or minus 4. But that's not what, but r equals 2z plus 5. And so we're going to have to write this out as two equations. And so now this here goes back in for r. So I would say 2z plus 5, it's either going to equal 4, or 2z plus 5 is going to equal negative 4. So again, both of them, I'm going to subtract 5. I end up with 2z equals negative 9 over here. 2z equals negative 1. Divide both sides by 2. do them both equations, z equals negative 1/2 or z equals negative 9/2. You'll get one or the other on those. And so both of them are actually the solution. Completing the square. I'm going to go ahead and tell you that this is one I don't like to do the least. So I'm going to go ahead and do this one. So this one, I want to go ahead and write it out like this. So we want to find out what c to put in here. So I'm going to write this out as x squared minus 8x. I'm going to put a plus in a space, 4 and a plus in a space. So to find out what this will be, I need to know what b is. Okay? B, all I'm looking at is b. Don't care about a, don't care about c at this point. I'm just going to look at b. And I want to know, how do I complete the square? So this one I say, okay, b is negative 8. I want to know what b over 2 is. So b over 2 is negative 4. And now I want to look at b over 2 squared, which means I'm going to square it and make that a 16. So I'm adding 16 to both sides. Now it just becomes a factoring thing in simplification. So the left side, when you do completing the square, it always factors into x plus b over 2 squared. That's how you would write it out. So I've got here would be x minus b over 2 is negative 4, so it's minus 4 squared equals 4 plus 16 is 20. Take the square root of both sides. I've got x minus 4 equals plus or minus radical 20. Well, since that's not a perfect square, I can't simplify it, but I can simplify as far as I can, and which means that's radical 4 times radical 5, because it's 4 is a perfect square, goes into 20. So x minus 4 equals, then that's 2, so that's plus or minus 2 radical 5. But since I want the exact answer, I'm going to add 4 to both sides. X equals 4 plus or minus 2 radical 5. And that could be a possible answer. And if you want an approximation, go ahead and do that. But definitely know how to get the 16. Definitely know how to do that one. All right, so the first thing on example 7, I'm going to get the x's by itself and move the 6 over. So I'm going to add 6 to both sides. So I have 5x squared plus 20x equals 20. Now I want to go ahead and factor out a 5, because now I'm going to do a 5 times x squared plus 4x. I want to put a plus here, equals 20 plus. So I'm going to do the same thing. B in this case is 4. B over 2 is 2. And then b over 2 squared is 2 times 2 is 4. So I'm going to put a 4 here, but this is a 4 multiplied by a 5. So it's not 4, but it's going to be adding 20. So this becomes 5 times x. Remember, it's x plus b over 2. So x plus b over 2 is 2 squared equals 40. Want to get this by itself, so we can divide both sides by 5. So that's x plus 2 squared equals 8. Take the square root. I've got x plus 2 equals plus or minus root 8. And so x equals negative 2. So you want to subtract 2 from both sides, plus or minus. And that simplifies down radical 8. That's 4 2, which is 2, radical 2, is my answer. But again, know how to get the C. I'm just going to go ahead and tell you that again. Know how to get the C. All right. Quickly moving on, we're going to look at quadratic formula. So this one's got kind of a nice conglomeration on it. I could go either way on example 8, but I must put one side equal to 0. So what I want to do is if I want it on the left, I can move it to the left. So let's just do that. So I'm going to subtract 5x squared plus 3. I'm going to subtract that quantity over there. So if the 5x squared is positive, so we're going to subtract 5x squared. And I can do the minus 3 as well, because it's a plus 3 minus 3. So I'll do a minus 3 here, minus 5x squared. So now, I want to subtract. So I've got minus 3x squared minus 6x plus 1 equals 0. What I'm going to do here is now I'm going to find out my A, B, and C. So A is negative 3, B is negative 6, C is 1. First thing that I do is I'll do what's under the radical here, which is the discriminant, the b squared minus 4ac. So I've got negative 6 squared minus 4 times negative 3 times positive 1. I've got 36 plus 12, and that ends up being 48. I know I have two solutions. So x equals negative b, which becomes positive 6. Plus or minus. The square root, we already did that, which is 48 all over 6, which is, this is 6, is 3 times 2, or 2 times negative 3. We can just put this in the calculator if we want an estimate, but I like the real deal. So radical 48 equals 4 root 3. I'll let you look at that later. So x, since it's like this form, I'm going to leave it in radical form. 6 plus or minus 4 radical 3 divided by negative 6. So this negative 6 is going to go back in here and make the top negative. So x equals, and we can break this up if we want to. I can break that as negative 6 over 6, which is negative 1, plus or minus 4, or because of 2 we're going to 4 and 6, making that a 2 over 2 radical 3 over 3. So that would be my final answer there. And so here we want to look at how do we do, if I want to look at the number of solutions. So I always want to go ahead and do this one as solutions. So again, I want to start with A being 1 because that's on the x squared. B is negative 2. C is also 1. Again, b squared, 4ac. Negative 2 squared minus 4 times 1. That is 4 minus 4, or 0. So I know that there is one solution. That's all I'm looking at. But remember, if it's less than 0, we have none. If it's greater than 0, we have 2. So if it's asking for the number of solutions, good idea to tell me. So I've got 1, 2, 3 equations. So we're going to look at, I'm going to look at one of these. I'll let you work the other two because it's all about the same anyway. And this is choose your method. I'm going quadratic formula. No, not a big deal. So that because there's some things that we can look at. So I know my equation is this here. The function is right there. So the function negative 16t squared plus 160 represents the height in h in centimeters of the feather t seconds. How many seconds does it take for the feather to reach the ground? So we want to know, okay, when does h, when it hits the ground, what is the h? Okay. H is 0. Wow, we've got a quadratic formula here. So I can put the 0 in for h, and I will have 0 equals negative 16 t squared plus 160. So let's go ahead and list out our A, B, and C. And this one's going to be a little interesting. A, B, C. Boom, boom, boom. A is negative 16. B, there's no t term. So B is 0. C is 160. Okay? I want to solve this one a couple ways just so you can see it. So I know I want to look with, so I'm going to come over here and go b squared minus 4ac. Well, that's 0 squared minus 4 times a, negative 16 times 160. Well, when you multiply all of that together, you end up with negative 4 times negative 16 times 160. I end up with 10,240. And so it just wants how long. We don't want to leave this in radical form, so we put it in the quadratic formula. So x equals minus b, so that's minus 0, which is going to be just a 0, plus or minus the square root of b squared minus 4ac. But I know that it's this, so it's 10,240 all over 2 times negative 16. Well, that's not going to affect anything because it's going to be a plus or minus. So I end up, when I put it in the calculator, I've got the square root of 10,240 divided by 2 times negative 16, which is 32. I end up with 3.16 seconds. And when I do the negative of that, I add the negative in there, I get a negative 3.16. So x can be 3.16 or negative 3.16 seconds, meaning that, or t, I should say. Since t is those, remember time can't be negative. So it ends up that we reject this one, and this is my only answer. I can also do this without doing the quadratic formula. I end up with, I add t. I'm going to add the t squares to both sides because I can get it by itself. So I add 16t squared. I end up with 16t squared equals 160. Divide both sides by 16. T squared equals 10. T equals the plus or minus the square root of 10, which is 3.16. And so I reject the negative and have to say t is 3.16 seconds. Or if they want it out, the feather hits the ground after 3.16, not 61, 16 seconds. Yeah, I'm gonna leave those because I'll let you work on those on your own. I may post those later, but I hope this helps you. Have a good evening.